All right, in this I'll be basically showing you where the product rule for derivatives comes from. So let's say we have pretty much a product of two functions, f of x times g of x, right? And let's call that h of x. We want to pretty much find h prime of x. So what is h prime of x going to be? We could pretty much use the limit definition. So we have h prime of x is equal to the limit as h approaches 0 of f of x plus h times g of x plus h minus f of x, g of x, and that is all divided by h. So here we see that we have our general expression now. And what we can do here is simply just go ahead and manipulate our numerator because that is the main goal that we want to achieve. So what can we add and subtract here? Well, notice we have f of f plus, notice we have f of x plus h and minus f of x, and similarly g of x plus h and minus g of x. So you pretty much have to add something that we could factor out here. So let's look at just the numerator. So we have f of x plus h times g of x plus h and minus g of x times f of x. And I want to write it like this so that we could see like the similarities, right? Because if we look at this, this is simply g prime of x. But we can't simply just say that. But we can get the fact that the limit definition is going to apply as well for the manipulated version of f and g. So here what I'm going to do is add f of x plus h times g of x, right? And subtract that as well. F of x plus h times g of x. So here now we have 3f of x plus h's, which is what we want to focus on right now. So we see that we could go ahead and factor out this from, let's say, this. So we will have f of x plus h times g of x plus h minus g of x. And similarly, we have the middle term that's left in pink, and we could factor out a g of x. So we have plus g of x times f of x plus h minus f of x. And since pretty much everything is divided by h, we could simply just split it into two different fractions. And here we could pretty much include the h simply just inside of our expression for g, which is going to be over h. And for the pink, we could do the same. And if we go ahead and simply look at the limit of each, we will see that we have the limit as h approaches 0. And the same thing could be said for the pink counterpart. So we see that we have the limit as h approaches 0. And here we can see that we have our limit definition for our example here. So if we plug in h equals 0, we're going to get f of x. And since we have g of x plus h minus g of x all over h, that is simply the limit definition for the derivative of a function g prime. of x. And for the pink counterpart, it's going to be the same process. We have plus g of x and limit definition for f. So it will be f of, or f prime of x, which we could rewrite this as f prime of x times g of x. So pretty much we already found the derivative for a product of two functions f and g. So h prime of x is going to be f of x g prime of x plus f prime of x times g of x. So that's pretty much how we get the product rule. It's just noticing the pattern where we see, okay, f of x plus h and f of minus f of x. We could rewrite that as our limit definition for f and g and get f prime and g prime in terms of using the limit definition. So yeah, that's pretty much the whole process of how to get the product rule for derivatives. So thank you for watching, and hopefully you learned how this always works or where it comes from. So yeah, see you.